significant. Now, what's more important here is the fact that when we give an answer after we do a calculation, we have to express the answer properly in terms of its precision. Therefore, we have to express the answer in the proper number of significant figures. So for multiplication and division, the rule is as follows. You round the answer. That means you re-express the answer to the factor with the smallest number of significant figures. So in your measurements, whichever one has the least precision and thus the smallest number of significant figures, the answer is controlled by that factor. And so whichever one that is, the answer is going to have the same number of significant figures as that measurement. For addition and subtraction, you round the answer to the place which has the greatest uncertainty. And I'll show you what that means in these examples that are coming up. So let's look first at this first problem. So we have 3.609 times 12. All right, let's look at 3.609 times 12. How many significant figures are here? Answer that in your head. It's 2. And here, this is between two non-zero numbers, so this 0 is significant, so there are 4. 4 versus 2, so the answer can have no more than 2 significant figures. And the answer here is, on your calculator, is 43.308. So your answer, as printed out on your calculator, has 5 significant digits. However, we just said that you can only have 2. This is the smallest number, so you have to get rid of these. So your answer is either going to be 43 or 44. And since this is less than 5, less than half, you would round down. And so the answer is 43. 1001 plus 23.981. Okay. Now it's best to write these addition and subtraction this way. Let me look at that again, 981. And our answer is going to be 4.981. Now, the greatest uncertainty here is the last one we know is the ones place. This is where the uncertainty for this measurement starts. And so it controls the answer, the precision of the answer. The precision here is to the ones place. The precision here is to the thousandth place. The least precise is this 1001, and so you have to move it down here. And this number is greater than 5, and so the answer is going to be 1025. And you don't have to put a decimal there because this is between two non-zeros. So you see you have 5 and 4 here, and just in this case it just so happens that this is 4 and this is 4. But if this would have been 981, it would have still been to this place. Okay? Let me show you what I meant by that. Let's say it's 981 plus 23.981. Again, we have 81940. Okay, so there's your answer. Again, its uncertainty begins at the tens place in this number, okay? This spot right here. And so, again, you would eliminate this, and it would be 1,005. You know, this has 3 significant digits, so unlike here where it would be 3, the answer has 4. But the uncertainty begins at the tens place, so that's why we have this. Let's look at another one. We've got 45.3 divided by 9.0342. So 45.3 divided by 9.0342. You get 5.0142791. Okay, this has 5 significant digits. 1, 2, 3, 4, 5. This has 3, so this is the controlling factor. So your answer has to stop at 3, which means you got to get rid of the rest of this. Since this is less than 5, you round down to 5.01. One more. 45.1 minus 22.9823. 45.1 minus 22.9823. So we're subtracting here, so that's 7, 7, 1, 0 is 1, 2, 2. Again, your uncertainty begins right here. So you need to get rid of this. And so this is less than 5, so the answer is 22.1 in the proper number of significant digits. Now, if you have any questions about this, you can bring them up in class. Approximations. We don't do a lot of approximations in class. However, I recommend thinking about this because doing approximations helps you when you get an answer to understand if your answer makes sense. And if your answer doesn't make sense, then you know you made a mistake and you need to go back and correct your mistake. So let's take a look at how to do approximations. Approximation is an estimated value based on prior experience and reasoning. Let me give you an example. So first of all, you select a value with which you're relatively familiar. So let's say you know that the average person's height or an average person's weight. Then you relate that value to something unfamiliar with a reasonable ratio. So for example, if you're trying to estimate the weight of a gorilla, you would say that gorilla is about 3 times as big as a person. You know that a person weighs a certain amount, and you use that relationship to estimate the weight of the gorilla. So the gorilla is about 3 times as big as a person, and people weigh about 170 pounds, and so that gorilla must weigh about 500 pounds. So that's how we do approximations. If you look at this example, a bank stack contains 100 $100 bills. 100 times 100 is 10,000. How many stacks would make up $1 trillion? Now, $1 trillion, another way to do this, by the way, in this situation is to look at scientific notation. So let's look at a scientific notation. 10,000 is 10 to the 4th. It's 10 express 1, 2, 3, 4. So it's 1 times 10 to the 4th, or 10 to the 4th. A trillion, which I'm not going to write up here, I'll just tell you, is 10 to the 12th. Okay. So how many stacks, if there are X number of stacks, and they're each contain 10 to the 4th, how many stacks would it take to get to 10 to the 12th? So x would be 10 to the 12th divided by 10 to the 4th. When you divide, you subtract the exponents. So 4 subtracted from 12 is 8. So it would take 10 to the 8th stacks. Now 10 to the 9th stacks is a billion. So 10 to the 8th stacks is 100 million. So 100 million stacks would be required in order to have... So we finished our slides here, and I would say that once you go through the homework, if you have any questions, please feel free to bring them to class on Monday, and we will go over those questions. I will also, if their time permits, give you more examples. And the first quiz will cover these principles of approximation. There's one other thing I wanted to show you about using approximation. Let's take a look at some of these things we calculated here. For example, look at this example right here. This is approximately 45 divided by 9. Now what's 45 divided by 10? See, in order to do an approximation, what I do is pick a division that's easy to do in your head. 45 divided by 10, so we're going to say 45 divided by 10 is going to equal 4.5, right? So your answer, 5.1, should be pretty close and a little bigger, since it's divided by 9 instead of 10, than your approximation, 4.5, which is exactly what you got. Now, if in your answer you got 2.63, you'd know these are not very close together, and this 2.63 is in the wrong direction, so you'd know that there was a problem here. If we looked at, say, this up here, if you said 160 times a half would be about 80, and then times 10 to the 6th, 80 times 10 to the 6th, or 8 times 10 to the 7th would be an approximation. Again, your answer should be fairly close to that, and if you didn't get that, comparing these two answers, then you know you made a mistake and you need to go back and fix it. Just a little sidelight about how we can go about doing this. So with that, I'm going to wish you good luck on your homework problems and on the quiz coming up.